Morning everyone. Let's maybe wait for 1-2 minutes so everyone can join the session. Okay, I think we can start. As I see that everyone who is online in Discord has joined the stream. Right. Okay. So yeah, as you remember, yesterday we started doing some practical tasks, and as you remember, there was an issue that I was not able to actually run the the class. Run the class array. Basically, I was not able to run any class of this, and as you've seen, I had some strange outputs in console. And as I noticed already yesterday, that there was some problems with the execution of the class. And as you remember, I created another class here just to test if maybe there's an issue with these classes particular. But actually, the problem was that as you saw in console, there was it showed it shown us that it didn't recognize the class we were executing. So it just actually it said that the class we are executing does not exist. What does it mean? It means that it was not able to see it. And as you remember, maybe you remember from the very first session we had this week, is that to execute Java classes, there's the class path, which allows Java to actually find the place where to search for the class to be executed. And yes, in particular in this case, why there was an issue with the class path is because of some strange behavior of Eclipse. You may expect it sometimes, and as you already mentioned it yesterday in Discord, that it is possible for Eclipse to do some crazy stuff. But yes, to solve it, what you need to do, go to project, as I remember. No, not to project. Um, Here, there was a setup for the class path in Java, and okay, yeah. Here, go to your project properties, and here you have Java build, and here you have basically the source, the project, the libraries used in this particular project. And in this case, here you show the build class path order and exported entries, and here's the place where just all the stuff which is used in our project needs to be selected. So what I did is I just selected all and applied. So it means that every path from this will be used in the project, and after that the issue the issue was solved, right? Yes, and yeah, all other steps had been done correctly yesterday before the fixes, so it was just a technical issue with Eclipse and no issues with the project, right? So yes, as you remember, we had the task to actually pass the parameters from the arguments to the array, which is the static variable of the class, right? Maybe again, let me use my favorite approach of using static attributes and methods. This is basically the approach I more like to use, to use. Right? You need to define the class, not define, but to write the class. Then using that, you access the class attributes, which are static attributes. So, and here we can do the testing for ourselves. So here we can just print the array, which will be sorted. As you remember, we need to go to run, right click on the array, run as, run configurations, and here you can pass the arguments. Let's, for example, pass 23, like 71 and 21, for example. Then just go run, and yes, here you can see that it shows us again, okay, maybe, yes, I ran different tests, sorry, just one moment. Yeah, here have arguments. Sorry, that's my mistake. I pressed on the wrong. Let's, for example, okay, I think this time it should work normally. Yeah, as you can see, the array is sorted and it's fine. And just last time I selected the wrong. Yeah, for last time I just selected. Sorry, button. I selected JUnit test, so it was not correct. Right, so from this point of view, we just did our own testing, and it shows the correct output. We don't need to print the array here. I think that was not mentioned in the task, and here's the unit test. So yeah, as I mentioned yesterday, for each particular class, for each particular task, you have the class for unit test. In this case, it's array test1. This is the class for unit test. And what we can do, we can run it. Maybe let's provide some arguments here. Right, for example. Right. Then let's run the unit test. And as we can see, the unit test is successfully done. We have the green tick, which means that our unit test is correct. Our solution is correct. Yeah, for you, just when you will be doing the home tasks, please attach the screenshot of the unit test, so I can see that your solution works correctly. It will be easier for me to check the exercise, to check your solution. Right. Yes, and let's move on. Also, yesterday we didn't finish the task about Black Knight. So let's maybe go through again, so we can just refresh a bit what we did yesterday. So yes, as you remember, there is a Black Knight, which is the class to implement the behavior of of Black Knights, which actually fighting somewhere in the war. Um, yeah, and as you remember, so first of all, there are some static variables inside the class. As you remember from yesterday's session, I mentioned that everything what is static in the classes, it belongs to the class itself, and everything what is not static, I mean instance, that belong to the objects with the reference to the class. So yesterday we started with yes, as you can see, the class starts with static attributes. So total knights, actually this is the actual number of knights, alive knights, dead knights, and this is the array of all the knights which are objects with reference to the class Black Knight. Also, as you can see later, static instance attributes are coming, which are used for the knights separately for each of them. So each of them has his own name. Then we can count number of his arms, legs, and head, and point if he is alive or dead. And first of all, we had to, and yeah, what was the task? The task was to implement all the methods with the required characteristics mentioned in comments. So first of all, we had to there's a question from Vienna. Oh yeah, sure, I can share the code. Do you mean this code or the code for array? Okay, I can maybe I can share both codes. So okay, I can share both codes with you. And so yeah, this is the second one. We actually haven't finished it yet. Okay, there are more than. Let me save it in Notepad first and then share it with you. Okay. Yeah, Zane, for array test one, this method is already created, so you don't need to do any changes here. You just need to run it as using run configuration, then pass some parameters for testing and put select JUnit array test one and run it. Actually, the code already exists in the project in GTM. We imported. So let me share the text file. Okay, let's continue with Black Knight. Yeah, first of all, we had to set up the battle, set up the initial parameters for the battle. So all of them should start with 0. I mean, the number of total knights, alive knights, and dead knights should be 0 at the beginning, and also the array of all the knights is initialized. So array of objects. Knights as objects. Then we have the constructor. We have the constructor to set up the initial parameters for each soldier separately. So it's obviously then, as for the persons, all of them at the beginning have two arms, 2 legs, and 1 head. And yeah, just to make it more clear, at first every knight is alive. Then as it mentioned, we need to pass the instance of the knight to array of all the knights. So we can just, let's say, register the particular knight there. After that, also increase the number of total knights and increase the number of knights alive, and set up the name. So as you can see, for all the parameters which belong to object, belong to knight, we use keyword this, just to point that we just pass the, let's say, global parameters for the exact knight, right? And yeah, for static variables, I use black knight dot, which means that we access static attributes of the class itself. And from my if we go back a bit to regarding the static and instance attributes, I think here you can see, maybe let's move it here just to make it more clear again. So as you can see, for the objects itself, for instance attributes, we use this, which means that we do the changes exactly in this as the object, and for static methods and attributes, we point that we change exactly everything what belong to the class itself and non-object. So changes for object and changes for the class, the changes for the knight and change knight as particular knight, and the changes for the, let's say, the class of knights, the general class of knights. Right, let's move on. Then we had the method which cuts off the arm of the knight. Here we had to check if he's dead, then just return the corresponding text. If number of arms, let's use this again, just to make it more clear. So, and yes, then if he has some arms, just cut his arm. Here, as you can see, since we have two statements which in theory can be false, both of them, then in this case we need to have another returning parameter, which is ha. And we don't need an else statement, since that would be the same here for this particular case. Right, then we had similar method for his leg. We just had to cut off his leg, basically in the same way. We check if he is, typo from yesterday. If he's not that, then if he's dead, then return this particular string. Otherwise, cut off his leg and return if nothing to do here. Again, cut off his head. So basically, it means that he will be dead. And in this case, just remove his head. Pass that. Write that he's dead. He's not alive anymore. Remove, decrease the number of knights alive. Then increase the number of knights dead. And yeah, as it is required task, we need to, if there are other knights alive, then we need to return the corresponding text of all the with all the knights who are still alive. To do it, we used a different we created another method which returns the corresponding string we need to pass to the output. In this case, we used string builder since we are mutating the string. In this case, it's better for the performance point of view to use string builder, not string, not just simple string object, right? So here we have the cycle which loops through all the knights, and yeah, if the knight is still alive, then pass it to the string and finish with the eliminator. So yeah, as we can see, in theory, if we go through all of them, we will finish with the comma at the end, which is not required here. So to do it, just use the substring. So we can just use the substring. Start with 0. Okay, let's maybe do it. Okay, let's maybe first of all check. No, I think it's better to do it separately, because in theory this can be initial in theory as well. I mean, the string in theory can be initial. So if no one is alive, then I think at least some of them should. Yeah, at least some of them should alive. So in this case, we can be sure that we will have this one at the end. So yes, since we know that there are still knights alive, we can be sure that the string is not empty. So let's just use the substring and remove the last character, right? Last two characters. So as we can see, there's space and there's comma. Yes. So and can move it, transform it to string as requested here. Right. Then let's return. You can see we use the private instance method, so it can be accessed only from here, from this class. Right. Okay, this is the name, so we need to add this particular string, substring here. Then as we can see, there's a space. Then the names are coming, and let's finish with this one. Right, I think that should be fine. And most likely this is pretty it here. Okay, let's maybe run the test. So as we can see, there's a JUnit test here again, so we can test. Most likely that we have missed something. Yes. Yeah, as we can Yes, what one moment. So yeah, as we can see, we have the output which is expected. So once we press here, we can see that there's a failure, and here we can see the actual code what was provided here. And yeah, I think maybe that was my yeah, I will explain so on one moment and just fix this issue. Maybe we don't need substring at all, right? And then let's check it again. Well, okay, seems that we have missed one space again. Just follow the instructions mentioned here, and here you'll find what's the issue with your output. Yes, we need another space here. Means that we need another space here. Let's run the unit test. Okay, we have oh yeah, that's another. I mean, I missed to put the right return here. As you can see, it's asked to return you'll burn hell forever. Instead of this, I used the wrong one. So my fault. We need to be careful. And yeah, here as you can see, we have successful JUnit test, which means that the code is correct. Yes, Svetlana, regarding your question, line 99. So as it is asked that, so we are at the moment on this point. So it is asked that if there are other knights still alive, then we need to return this this particular text. So this is the starting one. You will never. Yeah, sure, Wayne. Yeah, maybe. Yes. um, for line 99 and 100, as you can see, it is asked to return this line. You'll never win, which should be like a static one. And here we need to provide all the knights which are still alive, as it is mentioned here, are names of all of still alive knights. To use it, we created a new method which is called alive knights. We created it here. As you can see, it has the returning parameter. So here we just concatenated these two strings with the names of the knights which still alive. We need the return statement to. It is asked here. It is asked here. If there are other knights, then return this text. Right? That's why we need a return statement. So we just return this string as it is asked here. Right? Then yeah, we just implemented the method which returns as the array of, not the array, but the string with the names of all the knights who are still alive. For this purpose, we created a new method, name alive knights. Yeah, with all the knights alive. which returns, here we can see it returns the string, and we use it as the private method since we are not planning to use it outside the class. And yes, this is again one of the particular cases of object-oriented programming. From my practice and my experience, I consider private instance method. I mean, without the static, just private methods as and private attributes as the base attributes. So if we think about what's the way, what are the parameters needs to be assigned, not parameters but modifiers need to be assigned to the method, I suggest to start with private. So if you just first of all you need to think about if if it's private, then it won't be used outside the class. If you need to use it outside the class, then like think about it in the next step. So yeah, for example, if you want to use it in kind of subclasses, then you need to use protected access modifier. And otherwise, if you know that this is the method which will be used like everywhere outside the class, then please use public. And in this case, we don't need the static method since we are working with the objects, with the knights in this case. So everything what's happening here will be let's call it inside the object of knight. In this case is the instance method, and that's why we use this method as the instance method as well. We do not need static since we don't need to use it as the static. We just need to use it here. So this is the most simple way to define the this is the most simple, not the way, but the most simple like case. Just it's not complicated, then you need to use this somewhere outside of this, basically it's called of this object so we use private and instance method. Right, then let's move on. Here we use string builder, since as it was mentioned that string builder is more fast than just a simple string. So here we use delimiter just to know that, for example, for the first case, on the first once the first knight is processed, we use the delimiter. Which at first should be nothing. So we have just a simple, like for example, if there's a name. So here we have the first iteration, and what we can see, there's an empty string. Then we use, like for example, the name of the knight. Here, as you can see, the delimiter is initial, so we have initial string here. Then we concatenate it with his name. Right, then we concatenate it, and let's just move on. And yes, why I was a bit confused today, because I haven't noticed that we don't use this comma at very last iteration. So for example, for the second one, let's just imagine that we have another knight here. So there's the first iteration, then there's the next iteration, where here we got the name Edward, for example. And what we can see here, since in the previous iteration we passed the comma with space to delimiter, in the next iteration it will be comma plus space. So in this case it will be comma, we use delimiter, comma, and space, and we concatenate it with the next knight. And just in the same way we go through all the knights alive. And yes, we use append statement for concatenation. So we have the string, we use append, and then we concatenate. It means that we concatenate this string with the parameter provided inside the method. So this is one parameter. Yeah, just the plus sign, the concatenation sign is just it returns one parameter. And at the end, since it is asked that the returning type of the method is string, then we just convert the string buffer to string. And this is pretty it. Just before you run it, just be sure that every spaces are put in the way it is asked, right? With all the spaces here. And after that, again, let's execute the unit test. Yes, let's execute the unit test. Yes, I will explain you Sweat one a bit later. Just once we have unit test, and it returns us that everything is correct here. Yes, the answer to Sweat one, basically the unit tests in Java is basically this is also the code. It's a specific type of code. Maybe let me show you here. It extends one specific class, which we need to use. And then I will not open it now, but this is basically unit tests are implemented inside the class, which maybe I show you maybe a bit. Okay, maybe I can show it now. So here is basically here's the class. You'll not be able to see it at the moment, but yeah. So yeah, Christine has string builder. Okay, let me finish with unit tests. It's just so basically unit tests are just also the classes. I will show maybe a bit later how these classes look like, and what they does. They just do all the checks for the corresponding classes. In this particular case, it's for example Black Knight. We run it as unit test, and it just does all the testings required for our class. So it's already implemented logic to test our particular development. Right? This is just a simple explanation. So it's just a code which runs another code and just marks all the test cases to clarify if everything is correct. Okay, let's move on with Christine's question. So the error in unit test, string builder, some defined type. Maybe you don't have. I think you should have. Java-lang string builder for your case. It's undefined for the type. Maybe Christine, you have some issues there with the code, because then this error message is a bit strange. Undefined for the type. It doesn't make sense of it, but Okay, maybe Christina, show your just maybe during the break or after the lesson, just send me your or share your code with me. I will check after that. Right. Yes, this is. Okay, I see there are questions coming. Yes, in case you have any questions, just briefly ask. Uh, yes, I will. Maybe yes, I can share it. I can share this my particular code here now. Just, so yeah, and okay, let's move on. So your home task will be to finish this particular package, and yeah, for the first you don't need to do the first one. So this is just a configuration we don't really need, but here we have another task. You can read, just create private structure for the person. Yeah, not the structure, but basically the attributes for random person to store his name, her name, age, weight, he's female, smile, and yeah, you will need to generate. Okay, this is another point we'll hopefully discuss today. And yes, about getter setters. So just you need to generate them, and yes, you're welcome to do the extra activities as well. So extra activity 1 was there are 2 tasks here, extra activity 2, 2 tasks here, and extra activity 3. Yeah, the deadline will be next Wednesday, before the lesson, right? So just let me maybe write this in Discord so you can follow it. Activity 03 finish, and extra activities. This GTM extra 101, extra 02, and 03. Optional. And then let that be Wednesday, so it's 26th of August, just before the lesson. And yes, we'll talk then next Wednesday. We'll discuss some maybe unclear points about all these tasks, if you had some. Right, so maybe yes, since it's pretty it for this particular package, we can move on with the presentation. Just let me open the presentation. Yeah, maybe are there any questions regarding the stuff we've done so far? And if not, then we can move on. I think yeah, we can, since the time is coming, I think we can have the break. We can have maybe since we have a longer session today, let's have a 15 minutes break, and then let's continue at 9 o'clock. Hello everyone, welcome back, and let's move on. So today we will start. I'm not sure if we will finish, but we will definitely start with one of the most important topics in Java. Since yes, as I already mentioned, and you already know that Java is very object-oriented programming language. So this topic about object-oriented programming itself and the principles in Java in particular is very large and very important. Okay, let's start. So let's go with the main ideas of object-oriented programming. Um, you already, I think we already had the slide in very first or in the second session. One moment, I have the question. In Discord. Let me check. Oh, yeah, that's okay. Oh, yeah, I will discuss. Marita will answer you during the next break. Right. Okay. So let's move on with the presentation. So yes, as it was mentioned, the main idea of object-oriented programming is nouns over verbs. So it means that uh, we um, we have nouns as objects, and we need to like think about the objects like more than about the ways they're executed. So it means that in first place there's an object, and after that we look on the behavior of this object. So first of all, we need to understand how the object needs to be created, what is the hierarchy to be defined for the object, and then we'll think about how to use it and all the code and stuff located inside. Right? So yeah, first of all, let's first, as you can see there, the first main point of object-oriented programming is these two things, as we already discussed, classes and objects. And yeah, we'll talk. We already talked about some differences between what should we consider as the class and what should we consider as the object. We'll talk about it again later. But for the key point for objects is that every object needs to be constructed before it is used, right? So we cannot use anything if it's not constructed. So as in programming, we need to use the constructor to create the object. And in Java, every object has its own constructor. Maybe I mean, every class has the constructor to create the object. Let's move with the code examples. Let's create a new class. Um, constructors just to distinguish it. And yes, as you already maybe noticed, that we have the constructor, and all the constructors are the methods, right? So it's just a simple method which we can override this way. So of course you can skip this. In this case it will just create an object with no any particular steps done before the object will be created. In this case, and as in this case, it's just an initial method where there's nothing inside. Usually constructors mostly are used to initialize the variables of the objects, like all the attributes, some parameters, and so on and so on. So the objects, the constructors will be called every time once the object is created, once the method new is called. So in this case, once we call new, new keyword new is executed, then the constructor will be called, right? So have new, have the class, and then constructor is called. Yes, usually constructors by default are considered as public, but there are some cases when the constructor is defined. Okay, maybe let's just do it this way. Let's create another class. So this is different class now, right? This is different class, and first of all we can just have the same method here, and it should work. Yeah, we have a constructor. We can call the public constructor from different class. There is a case that the constructor can be defined as private, and what we can see in this case it means that we are not able to create the instance of object of the class for constructors outside this class. Why it can be used in some particular cases, just depends on the scenario, on the approach used. Maybe we'll not talk about all these scenarios now. Just to let you know that there can be such case then if constructor is defined as the private one. So it means that we cannot get the instance create the instance of the class outside the class. But what can we do? We can, for example, create static. Yeah, just to know that this method is static, since for example, what we want to do, we want just to get the instance of this class inside this class, and we don't have the object created to do it, right? So here we don't have this object, but we want to get this instance. So what we can do, we can create the method, for example, get instance. It's public static. Here we can put the returning type, which is the reference to the class, and here we can call the constructor here, since as we can see we are located inside this class, so we can use this method. So we can call the constructor this way. As you can see, we have static method which returns. Of course, there can be some logic added, some checks added here. For our case, it's just an example to show you how this one can be used. And here, what we can do, we can just ask this class to return us the instance, and in this case, it will work. Yes, this is just to illustrate you that it's possible that constructor is defined as private, so after that you won't be able to use the keyword new and create the instance directly outside this class. Right, this is about the frame. Of course, constructors can have. We'll have the topic about constructors, so maybe let's talk about it later. It's just some beginning. Right then, yeah, as you already know, the classes have their own attributes, which can be static for classes and again instance for objects. Same about methods. The abstraction, we'll talk about inheritance and polymorphism later today, but yeah, as you know, the class can be extended from different class, and the polymorphism can be used as well to override the methods. We'll talk about it today later. And okay, let's move on. We'll talk about some general design principles for object-oriented programming. The first is maybe one of the most popular ways, just top-down design. We'll talk about it today, and also we'll talk a bit about cohesion and coupling as well, and about composition too. Yeah, as you probably already heard, some very important terms related to object-oriented programming. First one is inheritance. When you extend the class with a different class, so in this case it inherited some properties of another class. In most usual cases, these properties are attributes and methods, which are defined as public or protected. Again, the private attributes and methods will not be inherited, and the same is about the static methods and attributes. You will not. It is not possible to inherit them. Yes. Okay. Let's move on with the encapsulation. Also, it's a mechanism of wrapping up the data and code together as the single unit. So we have again the methods and attributes, which are, it's called like encapsulated inside, taken from one class and encapsulated in another class, which can be used in the class which used inheritance. Then there is an abstraction. Abstraction is used in like most of object-oriented programming languages. You'll face it in C++, in C as well, and of course in Java. And it's a very wide term, which contains such things like abstract classes, abstract methods, interfaces, and so on and so on. So abstraction is the thing that allows us programmers to not implement, that's called like not implement everything, just use the classes or the interfaces to create a scout for all the construction of basement, for all the construction of the method of the class which is going to be implemented. And of course there's polymorphism, which is used for mostly for methods, functions, to use multiple forms for it. Like if you pass different variables to the same method. For example, there's basically method with the same name, but it asks it asks different parameters. So in this case, it's called polymorphism, where this approach is used. So have, for example, again, multiple methods with different parameters. Like, for example, let me show you the most, maybe the most basic case, the most understandable case. So let's moment just okay, yeah, let's maybe do it a different one. So yeah, just sorry, I'm just was a bit confused. No, not the polymorphism just used for the classes to override them, to inherit them. For example, let's have the class shape, for example, and we have just a primitive method. For example, sorry, wait. For example, I want to draw and maybe let's have some. Okay, we don't. For example, for all the shapes, we have some parameters. I'm not sure if no, there's no common parameters for all the shapes. But okay, imagine we have we have the rectangles or parallelograms. Maybe okay. Let's okay. Sorry. Let's let's delete it again, and maybe I will show you with the square, right? Yeah, I think that would be better. So we have the square. As you can see, square has just, for example, have the width. Okay, sorry. Maybe, yeah. Moment. Okay. Yes, I think that would be. Okay, maybe let's just go with like size, because I don't quite want to think here. Let me choose the better. Maybe show you the better. I think yes, we can use. Maybe let's use length. It will be more. It will make more. That makes sense. Yeah, for example, yeah, let it be square, right? So we have the square. We have and yes, and we can use it as the parent class for example, let's use it as a parent class for rectangle. rectangle, let's extend and yeah, here we'll already see that. For example, let's create the void. Yeah, maybe let's create public rectangle, and yeah, this is the constructor, and as we already can see that we have the attribute length available. So this is the inheritance of the class, inherited from the class square. We can provide the parameters to the method, to the constructor. Yeah, the same is here. We can provide them. And yeah, we can set up the one, for example, which is the importing parameter. And for example, but what's the difference with the rectangle? Yeah, as you can see, it is already, yes, and yeah, here we have the super method super, which calls the constructor of the superclass. And as we can see, if the method of the if the constructor of the superclass is defined with the logic, so we need to call for the superclass here, and after that we can basically, since this is the same code, we don't need it. So in this case, basically all the both the constructors are different, but for what's the difference for squares and rectangles, right? The difference is that rectangle is maybe more complicated case, since it has different, basically the sides are different, right? For both these cases, angles are the same, 90 degrees, and yes, we have weight. Yes, here we can see that already the length is already inherited here, right? It is inherited from superclass. It's inherited from the superclass, but what we have in rectangle, we have length, and of course we can define width as well, right? Can define width as well. So we can initialize it as 0 integer, and here we can see that basically we cannot use the same constructor, so because both so for squares we need only the length, right, since all the sides are the same, but for the rectangle we need to pass the width as well. And I need to use comma. So first of all, we can call the superclass to initialize all the parameters which basically belong to the superclass, which is square, and also we need to initialize the width. Right, and yeah, this is called polymorphism, where the same, actually not not yet. Maybe let's, yeah. What else we can do for the square? For the square, we can calculate the area, right? We can, for example, get area. Can get the public integer, right? Let's return. Let's return the area, which in this case is just the length, the power of 2, right? So yeah, since this is the public method, so as we already know, the public methods will be inherited. Just, yeah, sure. So that one I will explain. Yeah, just let me maybe finish with this one and with the polymorphism. And yeah, one moment. Yeah, as we can overwrite. So we use this command to overwrite the method, and here we can see there's the method which is public and get area. Yes, it's, yeah. So this length times this width, and yeah, as you can see, now we have a different method for to get area, and this is called polymorphism, where you have basically the same interface. Like in this case, the interface is for square, and maybe let's create a new. Let's create let's create a new class. Just another case to be sure. Free parallelogram. So we have parallelogram. Okay, and let's, yeah, okay, we can also in Eclipse we can define the superclass directly here. If you can just browse it, and it's not actually the rectangle, but we can use it. We can use it as the rectangle, and what we do have with parallelograms is there are some more parameters, and in this case these are the angles of the corners of parallelogram. So there are two angles need to be provided. Let's call it yeah, basically two sides are parallel as for all this way we call it right angle and maybe right bottom angle. Maybe let's set up by default as 19, so it will be same point left bottom. But it still extends all the features defined for the square and for rectangle as well. Since, as you know, the parallelogram is just a special case. The square is just a special case of parallelogram. So we have the square as the most simple case, then we go to more complicated case of rectangle, and then we can go to parallelogram, which is more complicated case of the rectangle. So this is called polymorphism when the one interface can have multiple different implementations. Okay, here we can define the public constructor again. Here we need to provide okay, we can use the length as the okay, maybe not the length, but we can use the height. So yeah, I think that would be better. And yeah, basically as you can see, you can improve your code every time. So I think yeah, that height is more appropriate thing to use. Yeah, so it was my fault. Yeah, that's yeah, we use protected since we don't use this one outside our hierarchy, and in this case we also want to use it as protected, right? So yeah, protected as, okay, let me maybe remind you that all the protected methods and attributes will be inherited in the subclasses. And this is basically what we need, since we do not want to access the attributes of the class. We define them as protected outside the class. So in case you have another class, you cannot directly access these attributes because you actually don't need to access them. And yes, here we have a method which gets the end. Let's construct the parallelogram. So as you know, yeah, parallelograms have two different angles on left and on right side. In this case, it's just a simple rectangle, but so you need the height, you need the width, you need let's go for left angle, just not to overcomplicate it, and right angle. Integer. Right, and yeah, yes, and we need to call the constructor of the superclass again. Yes, just this way. And here you just provide the parameters from here. And yes, this is what is called polymorphism. We have square, which has just a basic attribute of height, as you know, just a square, which has all the sides with the same size, and all the angles are 19 degrees. So this is just a square. And in this case, it has the simple constructor, which just asks us to just pass the length of the high, right? We don't need this method at the moment because I don't really want to show anything. So, and yeah, for example, if we have the method area, we need to um, just multiply height with height, and we will get the area. For the rectangle, here we have basically, from my point of view, the most interesting point here is the constructor. As we can see, constructor just sets up the high in this case, height, and same here. We call the constructor of the superclass, which will set up the height as well, and in addition, it will set up the width. So now we will have two parameters set up, and actually the parameter height is inherited from the class of square. And here we have the overridden method getArea, where we in this case we multiply. We have different implementation here where we just need to multiply the width and the height to get the area of the rectangle. And yeah, the most complicated case from all these three is parallelogram. And in this case, we have again the superclass, which the call of the superclass inside the constructor, which will call the constructor of the rectangles class, which will call the constructor of the square class there. So we have this such hierarchy. We go from the easiest case to more complicated. And here we can just set up all the additional parameters we have, and the same for the left angle. So now we have constructed all the attributes of parallelogram. Right, and again we have the method to override. Just don't use this twice. Yeah, by default it goes to super. We don't need it here. We just however, in this case it will work the same. The area of parallelogram is just maybe let me just show you in Paint for you to make it more clear. So we have the parallelogram. I hope I will draw it. So this is parallelogram, and yeah, the area of parallelogram is the height multiplied by the width. So in this case it works the same way as the rectangle does, and this is what it is. And all this schema is called polymorphism when we have the different implementations of the same class. We'll talk about it later as well. It's just an illustration. And yes, encapsulation is the way to wrap some data and to not use it if it's not needed. Again, right? Hope it's more clear for polymorphism. It's just again the ability of variable function or object to take multiple forms. In this case, in theory, again, the 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 square can have multiple forms. Not square, but the parallelogram can have multiple forms of, like a parallelogram can be the rectangle and it can be the square as well. So in this case, it's polymorphism. Okay, let's move on with the class. The class is an abstraction of items, objects, right, with similar structure and behavior. Yes, in programming, class is used as a template to create a similar objects and handle them in a similar way. Right, this is the correct. You can use classes in different ways. In theory, basically, there are several approaches to so different ways to use it. Like yes, if you want to be 100% object oriented, it is less likely that you use any static attributes or methods. You just push everything inside the object and push everything inside as the instance methods and attributes, and you can deal with the objects using them. And another approach is to use, for example, it's possible to use just the static methods and attributes in case you have some code, some code or different codes which do not require the objects to be created. In theory, that can be kind of, in my experience, it's mostly like kind of utility classes where you actually don't need the objects to be created. You have, for example, the methods, just a simple method, read this, maybe from database, maybe read something from database, or read this using that. And in this case, it's just like a method which has its own code. For example, you pass something to this method and it returns you something, and you don't interact with this method anymore. Like basically, if you call the method, if you do any change, if you call the method, it will not do any changes inside for this class, for this particular class. It will stay the same. Right? Yes, the declaration of the class consists of, again, access modifier. It can, as I already mentioned, can be the default one, which is nothing. I mean, there is no specific modifier for default. It's just you can write class with no access modifier. It will be considered as the default one. You can use private, protected, or public. Then the class keyword is coming, class name. It's asked to be in uppercase, and pair of braces to start and to finish the block of the class body. In Java classes supports following main object-oriented features. Again, we said encapsulation. This is for why we need to use access modifiers. The default, private, protected, or public. Inheritance, when you want to inherit any methods or attributes from the superclasses, and the polymorphism when we have different implementation for one particular class. We'll have some more examples a bit later. Let's move on. Of course, as for everything in Java and everything in programming, class have their own naming conventions. We usually use, mostly all the classes should start with uppercase. You can use the camel case, like, for example, you have any words, and then you have another words. You can start all these other words inside the naming with uppercase, like account is in uppercase, and so on and so on. Class declaration in Java. Yes, again we faced it a lot of times already. And yeah, we have access modifier, public in this case. We have class and the name of the class. Then we declare all the attributes and methods for this class. Alright, let's move on. Let's move on. As already mentioned, there are attributes declared in the class. We put modifiers, access modifiers, and if you want, you can use static if it's a static attribute. Then again, the type and the name. This is in general, and in particular, you can use the initialization as it is used not in this case, but in most cases, as you already seen, we use the initialization of the parameter of the attributes. Yes, right. And this is the classic example of the class foo. There's a public instance attribute. Here there are two attributes, instance attributes. The first one is the public one, and the second one is the default one. We already had the discussion about the access modifiers. What's the difference between default one, public, protected, and private? We'll get back to it again later, but yes, you can see that different modifiers can be used here. Of course, we can initialize the attributes if we want, if we need. And yes, attributes are always declared inside the class. It's true. Global, yes, we consider them as global variables, right? So we have such term that all the variables which, for example, we have the class, right? Maybe let me show here. We have the class. We have the attributes which belong to the object, to the class as the object, and yes, this one are called as global attributes. So if you hear the term global attributes, you just need to know that these are the global attributes which are defined globally inside the class. Otherwise, if you have the method and you declare, like for example, here's the method, you can declare into local attribute, just like this, local attribute, for example, just doesn't matter. So this one is considered as the local attribute. So this one is local one, and this one, and these are the global attributes. Right. It's should be pretty clear. And yes, again, we can have static methods and attributes, which, as I said again, I can say it again, belong to the class. So I consider them as the class attributes, and the instance attributes are considered as the attributes which belong to object. Also, we can define constants. I think we haven't talked about it. It's just yet we defined them as static, since it makes sense that all the constants are static. For example, you cannot it makes sense that you cannot declare the instance attributes as the final ones, because it actually doesn't make sense, right? So you cannot if the attribute is constant, it should be static every time. I can think in this case, it should be static. For example, it doesn't really matter. And in static final. And as you can see, Okay, maybe let's use the uppercase as it's requested. And as we can see, the problem is that we need to initialize them. Not integers, sorry, let's use double. I'm sorry, string, right? Yeah. Okay, and yes, as we can see, we cannot declare it as. Oh no, we can, but it will be considered as the constant as well. So it doesn't really make sense to declare the instance attribute as the final one. So I suggest to use static. Of course you can, but in this case, for me, it doesn't really make sense. If you have constant value, why don't you use as the static? Because basically every object you can still use it in every object, but from my point of view, there is no actual sense to use the non-static constant for the classes, right? Okay, let's move on. And yes, not most, but usually constants are declared in uppercase. Everything is in uppercase. And in case you want to just have any separation, we usually use underscore. Right, we use underscore to separate, for example, two words if you want from the for the constant. Right. Okay, let's move on. Yes, object. Yeah, as we started with the classes, let's move on with the objects. So yeah, as you all know, objects are the items, the instance of the class. So object will be referred to the class. In difference with structure, object contains both data, and it has data, which are the attributes, and the methods, which do the behavior, which define the behavior of the object. And yes, it's possible that there can be other objects inside the objects. Yeah, pretty makes sense. Like most usual case, it's string. It's the object, and you can use the object inside the object. And yes, structure can be used. Structures can be created in two different ways. Again, you can declare it using new object or just defining using the static structures. And yeah, in general, just for your understanding, what is the object? Object is as considered as the reference and the variable. Basically not the variable, but yes, we can consider it as the variable. Maybe not the best word to explain it, but I think it makes sense for you that there is the reference, which points us to the object, and there is the data, which is located inside the object. Right? Yeah. For example, we show you the difference between the class, and it's most usual case to understand. For example, if we have a computer like Lenovo T460, in this case, this will be considered as the class. And if we have a particular Lenovo T460 with the, for example, serious and specific serial number, this will be considered as the object. And again, to explain you the difference between again the static and object attributes, for example, for static and instance attributes and methods. For example, for the computer, there can be as the attributes any defects, for example, like broken screen, cracked screen, some issues with keyboard, and so on and so on. This will be, of course, the part of the object, since in general the class of the computer should not have the defects, by maybe the just don't have the static defects. That maybe it has the defects which belong to all the class of the computers, like some incorrect software is also considered as the defect. So in this case, we have the static attributes of defects which belong to all the class of Lenovo computers, and we have the instance attributes which points to the defects for each computer separately. And the same about methods. We can, so if we have some static methods for the class of this particular of the class for Lenovo computers. So for static, it can be like it's the general update, general release of the updates. So in this case, we can use it as the static method. So we call it from the class, and it will do the changes for all the computers. And the instance method can be like if you want to clean your, for example, you want to clean your hardware, you want to clean your computer, just remove any files from it. So of course it will not be used as for all the Lenovo class. You will just do the changes for your old computer. Okay, we already talked about the constructors. Maybe we can have a short break now, 10 minutes, and let's continue after that. Hello, welcome back. And maybe one small remark. Maybe just again regarding the polymorphism, just maybe to be clear, what did I mean is basically again it as I already said, the polymorphism is just when different methods, classes with the same name has class with the same methods, maybe even attributes with the same name have different implementations. So in this case maybe that would be a bit complicated. We'll not go deeper. Just imagine we have the method getArea for basically for in theory it can be even the same class. It can be defined as the same class, but we can see that it has different implementations. We'll talk about it deeper since this one is related to casting, to class casting, and that could be a bit complicated at the moment. But if we talk about, if we can talk even about some yeah, for example, we can call about some simple case. Any simple case. Let me just find what any simple case we can create here. Yes, Greenberg will. Helena, we will talk. I will answer you after the session, so we can finish with the polymorphism at the moment. Basically, okay, but just let's ignore that we are in the square class. I will just, for example, get. However, we can use the same class, right? If we, for example, we have the getArea, which is part of the square class, which is part of the object which has the reference to square. But for example, let's imagine we want to use different parameter, for example here, and in this case we have again, we have the same method, but it has different parameter, and we must return. In this case, it will be almost the same, but it will have parameter which is provided. So in this case, we have the method getArea, method for the object with the reference to this class, but we can see that for this particular method there are no parameters provided, and for this one it is parameter. There is a parameter provided, and based on this, if we provide a parameter or not, it will call this or this method. So this is also a part of polymorphism when the method, basically method getArea, has different implementations. And yes, maybe also one point about encapsulation. Again, as I said, it's the way to hide or even to show the parameters, to just parameters which are needed and which are not needed. For example, in this case, we defined this as protected. We defined the global attribute height as protected because we don't want to use it outside the class, right? So if we don't want to access it outside the class, so if we have actually a different class which uses square as the object, we will not allow to access this attribute directly. Instead, please just use constructor, or yeah, in this case just we can use just constructor to pass this parameter. But we want to use this parameter in the subclasses, like in this case in rectangle and parallelogram, so we actually encapsulate it inside this area and just pass it to, we can use it in all other subclasses, right? I think it should be a bit more clear now about encapsulation and polymorphism. And yes, let's move on. So the constructors, as I already mentioned you some things about the constructors. Let's just have a small repeat. Again, as it said, constructor is a specific method which is automatically executed to create an object, right? This is you already seen it today. Just 1 second. Small technical issue. So, yes, constructor should have the same name as the class has, and maybe one more thing. I showed you, it was on some on the previous, I think it was during the last session, or actually, to be honest, I don't really remember. But maybe, okay, let's create another class to explain you one small thing about so-called static constructors. For example, oh yeah, that's my fault. Let's rename the package. By naming convention, yeah, you already seen that package that we already discussed. That package should have the uh, uppercase naming, right? And in this case, if for example, if we want to create any class, okay, in this case it should work fine, but normally the package should have naming, should have lowercase naming, and as we have seen, just that it can complain that the naming is not really correct. But in this case, so I renamed it, and it should be fine now. As you can see, the warning message disappeared. And let's create them. Let's create another class here, and just to not interfere within the same class. So let's just create another class here, and let's create the static constructor. To create the static constructor, we need just to place static modifier, and that's it, right? And here we can put the code, and let's just for example print out just to point that we are here. Constructor is called, for example, right? Okay, and let's for example create kind of just a simple method, static void call. It's not true. Okay, we can have, for example, the method is called, and let's call it from the main method here, right? So, and let's execute the program. So we can see, and yeah, you even can notice the sequence, right? So we first of all, what happened here? We accessed the static. We accessed this class for the first time during the execution of the program, and the static constructor will be called every time. Actually, that would sound a bit strange, but it will be called every time this class is when this class is called for the first time. So actually, it will be called once per the execution of the program. This static constructor will be called. So in this case, we attempt to access this class. We just do the method call. In this case, static method, and before this method is called, as you can see, it calls the static constructor. If we want to, let's for example have just another method just to distinguish. For example, this one, and let's call this method. As we can see, the static constructor is not called for the second time, so it is called only once, right? That makes sense. If we want to access it for the first time, then it will be called. And what about? Sorry. And what about if we want to do some let's call some instance stuff here? And for example, let's have one instance method, just void public void. We cannot override in this way. Yeah, just another point is that if we have the static void and we have the public void, you cannot call it with the same name. From my point of view, it's not a bit correct that Java does not allow us to act this way, but let's leave it as is and let's live with this, right? So yeah, even if you have different decoration, if there's an instance on static method, there should have different names every time. And let's for example call the instance method. Let's create, maybe let's for now let's skip these method calls. Test just let's give a name, and let's call the constructor, and let's call the instance method here, right? So, and let's check what happens here. And as we can see, even in this case, it calls the static constructor. So just yeah, the main point is that the static constructor will be called once the class is used in static or in instance way, right? And if we have the object with the reference to the class, you call the constructor, even for example here, even if we only create the object, it will call the static constructor, and it will be called only once. So every time we access this class, in this case we call the instance constructor, not the static constructor. And yes, after that, or even not after, before that, the static constructor will be called, right? In case you have any questions about the static constructor, you can briefly ask. Okay, let's move on with the presentation. So yeah, for basic instance, in most cases we don't really use the static constructor. It's just for you to know that there is such possibility. In most cases, we consider the simple constructor, instance constructor, as the constructor which is just an instance constructor, and which is used to create the object with the reference to the class where this constructor is located. Right? If a structure is implicit, a static object constructor is invoked at program or when object is used for the first time. Yeah, this is what we were just talking about the static constructor. Yes, the default constructor. Yes, each class has at least one default constructor. If no custom constructor is created, then the default one is used, which just creates an empty object structure without any initialized values. So it means that all the primitive properties are empty or zero, and the object properties are equal to null. Right, makes sense. The general declaration of the constructor, we pass the modifier, the access modifier. As already mentioned today, there are cases where the constructor can be defined as the private one, so you cannot create the instance outside the class. Then you provide the class name and the list of arguments. Yes, you can also provide the arguments to constructor if you want to initialize the object with any specific values, like the weight in this case. And yeah, if you want to look more, you can check it in Oracle website. And yeah, as I already mentioned today, there can be different scenarios where the creation of the object with the reference to the class, for example x, is restricted. In this case, you can use again the private constructor, as we already discussed this case today. It won't be possible to create a reference outside the class. Right, let's move on with the value assignment. So as you can see, there are global attributes of the class can be used. You can initialize the values that way. You can initialize them also using the constructor. Then you can just pass the reference, and in difference with primitive data types, both object references point to the same object and structure. Right? If we have the variables here, for example x, y, then in this case, if we have, again, that was what I was talking about the reference. I think I can show the example now. So just before I show the example, just small actually with auto theory, that we have the variable which is defined as with the reference type. So my date is the class, right? Then we have an object. We create an object, and we have the reference of this particular variable. And here we assign the reference of the variable s to the variable t. And after it is done, both of them will have the same reference. And what does it mean? It means that if we change one variable, the variable with the same reference, will be changed as well. I mean, not the variable, but the content which is located under the reference. So in this case, this is the reference. So the variable has the reference, and the reference has the value. Maybe. So when I started to doing the programming, that was kind of a bit tricky thing for me. That even there are two separate variables, and if we change one variable, another variable will be changed as well. And that's pretty interesting feature of object-oriented programming. Okay, let's just create another class. Test references, for example. Right. Then let's create another class just to, or even we can use the same object. It doesn't really int, for example, a to b equals 0. Just default, and let's have the constructor. Let's create the constructor. In this case, we can even use it as a private one, so since we are not going outside the class, we won't go outside the class. And here we have also two parameters, int a, b. Right, then let's pass these variables to the global attributes. So right, and let's imagine let's create two objects here. The shortcut, actually, you just need to use Control Space. Actually, I usually use Control Space, and I have all the necessary stuff available here. And that's the answer for Vienna. Yeah, I really suggest to use Control Space when you write the code. It will increase the speed of your writing. It will multiply the speed of your code writing. And it also Control Space, it's like, for me, it's maybe the best shortcut as for programmer, because it shows me all the stuff available to use. So in this case, I can search if I can find all the stuff I need. I can find what I can. In this case, it's not like if I have the string, for example, string example text, have ABCD. It doesn't really matter. So in this case, I want to use this text. For example, I press oh no, that's the static one here. For example, this text, for example, and I press on Control Space, and here I can see basically everything, all the methods I can use. It's very comfortable, very easy to find basically everything what I want. So if I have string, if I have some specific specific, let's say, requirements or just thing I want to do with this string, or just like for example cut it or find some specific stuff inside, I can just use control space and find the method I want to use or the attribute or something like that. So it's basically this is what I use. I know there are some other shortcuts for the methods in Java, but for me it's absolutely enough to use control space, and I can just get all the stuff I want. So it's very cool. Right. Okay. So here we have the constructor, and let's, for example, create two objects with different values. In my case, test references, like for example, object 1. And let's call the constructor test references, and let's, for example, have 23 and 48. Then let's create another object, the same object, basically kind of similar object, and 12 and 23, but 27. Let's go. So have different one, and yes, and okay, yeah, it's fine for this case. It's fine for this case. Oh, okay, or maybe we don't even need this one. Let's just pass them system, and we have system out print 1, and let's print object 1 here. Let's change something. Inside the first object. Like as you can see, at first we had A23. Let's, for example, change it to 36. Right, and for the second one, yeah. For the second one, then should format the code. Oh, yeah, not that's different one. Here's the one, and yeah, sorry, I forgot to print it out. So, as we can see, here we have initialized the first object. Then we passed the reference of the first object to the second object, and here we checked that in this case the value is 23 as it was defined here, but then we changed the value of a in the second object, like not in the second object but using the second object. In fact, they're both are the same objects at the moment with the same references, and here we print out the same, and we can see that the value is changed to 36 as well. So in this case, this is the way the references are working, right? If we do the changes in the variable which has the same reference, that, for example, the original one or any other that has the same reference, it will change the value in every of them, in each of them. Right, yeah, this is the main thing how it works. Yeah, just a small schema for you. I want to consider the reference as the container, which actually points to exact area. Let's call it area of values, and inside this container you will find the values. So this is the way I'm thinking about it. Right, let's move on and let's talk about the way of accessing object members. So yes, class object properties and methods together are called members of the class, right? General syntax again to access the object is to at first place there is the object, right? And the variable with the object, and then we use dot to access the member. If it's the method, then we use round brackets, and if it's just an attribute, then we don't use any brackets here. We just access this attribute directly. Right, and yes, for object in which you are currently located in, you can skip this part, which is done in lots of cases, but yeah, I like mostly if you use keyword this, so it points you to the object, and if you use this point member, then you actually follow this syntax every time. That's why I like to use it, so it's pretty clear for everyone that you actually, if you use this, for some, if you don't skip this dot, you show other programmers that this is actually, for those who read the code, it's easier to understand that you are actually pointing to the member of the object, and not the member, and not the local variable, right? To distinguish the member of the class, the global attribute, with the local object, not the local attribute or method, right? Yeah, this is passed by value for parameters. It's the point in Java. If you already know, in other programming languages there are basically two options to pass the values, the parameters to the methods. One approach is pass by value, and another approach is to pass by reference. In Java only pass by value is used, and what's the difference is that let me find maybe, just let me try to paint it a bit. So if you have the method, so here's the method, and you have the parameters which are defined, like integer, for example, int, string, and so on and so on. Like, for example, int a, for example, let it be int a. So this is the method which has the parameter a, and if the parameter is passed as value, so you have, for example, code something here, somewhere here, which calls this method and passes the parameter b, for example, like integer b. It means that once it is passed to this method creates another variable, another variable which has the same value, which just where the value of b is passed to value a. So the variable a is created. So it's like additional place in memory. And in this case, if if the value of a is changed in some way, the value of b will not be changed, since in this case these are absolutely different variables. But let's check it with strings. What about strings? Since we know that strings are the objects. So as we know that with the reference it works in a bit trickier way. So let's create another class. Let's create another class. Test pass by value, for example. Pass by value, for example, right? Let's have method private. Let's call method be static. We don't need the object here. Static. Just let it be void. Void change string maybe. And then we have the string to be passed here. To be text and right, we just concatenated the original text with just 1, 2, 3, 4 out, and let's check what happens here. We have okay, let's create another string here just to be sure that we have the correct type. Okay, just to not confuse you, text here, for example. And we have 1, 2, A, B, C, D, for example. Let's call the method change string and text here. So many semicolons. And yeah. Okay, no, just yeah, that's true. We have nothing to be returned here. So yeah, this way. Right, semicolon, and run this program. As you can see, the string is not changed as well. So in this case, it means that it is provided as the value. So a new value is created inside. But okay, maybe let's check. Let's do this way as well. Just to be sure. And even if we use any method inside, then we just know that again the value is not changed. Even if we change it inside the method, it will not be changed after the execution of the method. In this case, it creates a new value inside and deals with it here. Maybe let's have another test example just to be 100% sure that it works this way. So let's have some integers. Okay, let's just have integer a. We don't really need any other integers then. Chef instance and change to 12. Right, and here let's create the instance. Yeah, and then let's call the method. Don't use control space too many times. Just once. Yeah, change ref. Just pass the instance and check what we have. System out print ln instance a. Right, and let's check what happens here. And for instance methods, for instance attributes, just okay, as we know for strings it won't work because strings are immutable. Every time you mutate the string, it creates a new value, as we just faced. But for the references, it's much more trickier. It's much more trickier because you can see that what happened here. We have created the object with the reference to this class test pass value ref, right? Then as we can see, by default this value is 0, so by that point value will be 0. Then we call the method where we pass the object with the reference to this class, and we changed the attribute inside the attribute of this instance inside the class. But as you can see, we have returned nothing from this void, so we just have the void where the action happens. And what we can see that at the result even here, when we went out of here we have the instance where the value of a is changed. This is how it works for the references, but let's have one more small thing. Let's basically change the reference of this value, this variable. Let's, for example, create a new reference and change it here. And what happens here? And here we can see that if we change the reference, it will have an absolutely different value. So this is a bit tricky point, even if we have passed the value to the variable to the method. In case if it's the reference variable, if the reference is if the reference is not changed, so like in this case the reference is not changed, we have the same reference which is provided from here. And if we let's maybe have here, if we actually provided the reference, we provided the container, right, and we did the changes inside the container. In this case nothing happens with the container itself, but the values inside the container are changed. But if we change the reference, in this case that will be an absolutely different container, like in this case. In this case we change the reference, so now this this variable has different reference, and we change the attributes of different reference here. This is also one of the trickiest point that also one of the tricky points that you can face in object-oriented programming. I also faced this one in my experience, and that was a bit strange for me for the first time. When actually, I'm working a bit different with different programming language, but there are also importing parameters, and in the language I'm working with, it is not allowed to even do some changes with the importing parameters by the syntax of the language. And for me, it was kind of strange when actually the reference variables were provided as the importing parameters, and at the result of the method, I seen that actually the variables, the values which are inside the reference, which inside the objects of these importing parameters, which were passed as the importing parameters, I actually noticed that the values are changed inside, and for me it was kind of how it's possible if it's not possible to actually change the values of the importing parameters, but it works differently for the references. You are not able to change the reference for the importing parameters, but you can change what is located inside the reference. So basically, this is the case when it is done. Right, I hope it should be clear for you now. And let's move on. So again, pass by. So and pass by values again is considered as the way when the importing parameter will not be changed. It will create a new value inside. And if value of primitive parameters changed itself, it doesn't affect any other changes. If object is changed and reference is not changed, then original object is changed as well. Right? Let's move on. Again, the keyword, the reference this, which is the instance of the object we are currently located in. I mean, if we are in the execution of the instance method or constructor, then we can use the reference this, which is actually which is also the variable, right? It is the variable, and it is the variable with the reference of the current object. And this can be used to, what I like to do, to distinguish object attributes with local variables or other attributes with the same name. It makes sense if we have multiple different attributes which can be considered as the polymorphism. Also, it can be considered as the polymorphism in some way. And to pass reference to current object as parameter for some method. Of course, if you need to pass yourself, not yourself, but pass the object you are currently located in to the method which is called from this object, you can use this as the variable. The destructor, as you maybe know, in different languages like in C, there are such things like destructor to finalize the life cycle of exact object, and is the method which is executed before the destruction of the object. And yes, Java doesn't have explicit destructor. Objects are destructed by garbage collector. So there's the method finalize. Maybe you already seen it. like here, just press Ctrl space, and here you can find that there is an inherited method finalize. Right here, it's already here. It's already here. You can override it if you want to do some custom implementation. It's rarely used, but just to let you know that it's possible to do something with it. And yeah, you can suggest collection by runtime garbage collector or system garbage collector. But anyway, object actual destruction is managed by garbage collector. So it's not. Usually there is no need to use the destructor in Java, since it happens automatically. It's a good feature of Java that you don't really need to care about the garbage from the class, from the object. Right, I think we can have a break, 10 minutes break, and yeah, after that we'll do our final sprint today and this week. Right, okay, so let's have a break. Okay, let's move on with the methods, right? Stop classified. Yes, as we already faced it, the classes usually have several methods, which makes sense. The methods can have the returning parameters, which are defined at the beginning. In the beginning, we'll see. Okay, we'll see it at the beginning of the methods, right? After the modifiers, and also there can be the methods without the returning parameters, like just simple void. But even as we just noticed, even in this case, we can have the case when the variable passed to the method can be changed if it's the reference. And yes, for the objects, methods usually represent the behavior of them. For static methods mostly represent they just don't represent anything. They just do some like, let's say, static stuff. And yeah, managed by, and the methods for objects are managed by their invocation from application. Right, with the main things of methods are they describe the actions, how behavior is performed, right? All these step-by-step stuff, what needs to be done, and what actually happens with the object. Then it hides the actual implementation from invoking code. Yes, and if we're talking about encapsulation, and if we inherit the some methods from the parent class and we override them, so in this case we can hide this implementation in this way. We'll talk about this stuff mostly later, but you already face some similarities to it, some basic things about it. And yes, methods can change object properties or state, right? As we already seen that we can change the global attributes inside the methods. And in naming convention, usually we start with lowercase, and if we want to distinguish the words inside the method name, we can use the so-called camel case. Right? For example, balance account. If we want to point to the word account, then we can start it with the uppercase, even if we start the method name with the letter which is lowercase. Yes, general syntax about method declaration. We provide the modifier, public, protected, private, or just simple default. Then we add the returning type, or we can skip this. We can use just void instead, and yeah, the name of the method, and the list of arguments separated by comma. And after that, we can move with the statements. Here, some just simple example of the methods. Again, methods are called using the brackets. In the brackets, we provide the parameters, and here's the example. I think we already seen it. With the doc, is the methods. Here's the void. Just sets the global attribute of the class. It's pretty clear. Yes, just to distinguish constructors and methods. So first of all, modifier. Yes, both constructors and methods have modifiers to actually show the visibility of itself, like its constructor and method, and to do all these encapsulation stuff here. In addition, you cannot you cannot put the modifier of abstract. You cannot create abstract constructor. You cannot create final constructor. Same, you cannot create native static. Actually, you can create static constructor, but it happens in using different syntax, and synchronized as well. Constructors do not have the returning type, right? They are just they work in the same way as the voids, work. Comparing to constructors, you can put any, you can declare any returning type of the method for the methods, right? Or just use void without them returning attributes. The name of the constructor should be the same as the name of the class. It starts with capital letter. It doesn't really matter in this case. It just needs to be the same as the name of the class, and that's it. In this case, you point that this is the constructor. For the methods, right, you can create different. You can use different names. Okay, usually you need to start with lowercase, but again, just check if there are no duplicates. You are not allowed to create duplicated methods. I mean, methods are considered as duplicates if they have the same name plus they have the same importing parameters. So in case you have different parameters to the methods with the same name, it's fine. It's also considered as polymorphism, where you have the different implementations of the same method, right? It is allowed, but it's not allowed to use the same pattern using the name plus the attributes. And also, you cannot use the class name as the name of your method. It is not allowed. Then for this, in all the instance methods, you can in constructor you can use this to point that we are currently locating objects, and as I mentioned it several times, that we cannot use this in static methods. It's prohibited. Okay. Again, it makes sense because in the static area we are located in a static area which belongs to the class, and we are not located in the object area, right? Inheritance constructors are not inherited. To use the constructor from the superclass, as we already seen it today, just need to call, maybe it won't be incorrect. It will be good if I show it again. Just here, if you want to call the constructor from the superclass, you just need to write super and provide the attributes, and this is the way you can call them. You can call the constructor from the superclass inside the subclass, right? Yeah, they're not inherited, but methods which are public or public protected or public or protected, they are inherited. They are inherited, and it can be used in Java this way. The default one can be, just so check default one default methods are inherited as well. So only private methods are not inherited. Let's see the question. Yes, about the superclass, maybe what I was talking about the superclass is, as we can see here, it is mentioned that constructors are not inherited. So it means that if we don't have the constructor, so in this case what we have the rectangle class, which is the subclass of the class named square, right? And in this case, if we for example skip the constructor, we cannot skip this. We cannot skip, and it means that it is not inherited. So we have no implementation of the constructor of the constructor from the square class, right? We need to create a new implementation of the constructor in the subclass. So here we are in the subclass. This is the superclass, which has its own constructor here, as we already seen. Here's the constructor, right? And here you can see that it is not inherited, and even more, it shows us that we need to implement it here. And again, you can see the error message that implicit superconstructor square is undefined for default constructor. We must define an implicit constructor. But actually to call the constructor from the superclass, we can type super and add the parameter here. In this case, it will call the constructor of the superclass. In our case, it's square, right? It will call this constructor from the superclass, and it will set up the height, right? Yeah, this is how it works. So the syntax is, you just need to write super and pass the parameter in brackets. It will call the logic of the constructor from the superclass, right? Hope it's more clear now. Yeah, I was just was talking about it because it is mentioned here that constructors are not inherited. I just wanted to show the way how you can use the logic from the superclass to actually to inherit the logic. Let's call it in the brackets, inherit the logic from the use, actually not inherit, but use the logic from the superclass, from the constructor of the superclass. We can do it just by typing super and pass the parameters in brackets. Getter and setter methods are very popular type of methods in object-oriented programming. Maybe you'll see these methods in your homework. For activity 3. Maybe let's test get set, for example, and also yes, right. Here we can generate okay, we can go directly to your activity 3. What is mentioned here, you can use select menu source, generate getters and setters. Menu, here you can see source. Here you can generate getters and setters. Oh yeah, first of all, you need to just again int a, h0, string, for example, text 1, 2, 3, 4, 1, and doesn't really matter. And for the, so as you can see, we have to maybe, okay, let's add access modifier private So now we cannot, we won't be able to access these attributes from outside the class. And to access them, to get or to get them or to change them by using the set method, you can again go to source. Here you can select generate getters and setters. Right, again, click on your class, go to source, go to generate getters and setters, and here you can select the attributes for which you want the getters and setters to be generated, right? And once we've done it, here we can see there are the methods created automatically to get the to set and to get the values of our attributes. Why do we need it? Because in some cases there can be some tricky points, like for example if we need to add some more complicated logic to return or to set the exact value. So for example, if you want to set the text, you can have some incorrect output, some incorrect input. Like for example, there's a user. Imagine the real, like any web application. There's the field where the user enters the value. So imagine you cannot allow the user to change this value directly, right? Because the user, for example, can add some incorrect value which is not allowed to be entered. And in this case, we cannot allow the user to access this attribute, and which will be stored somewhere inside the code. So in this case, we define it as the private attribute and use, for example, setter method to set this attribute and to check if the user typed it correctly by following all the necessary instructions. And yes, in case maybe also you can do some adjustments in user's output, in user's input. It's also possible. And for example, user entered the string with the space, and you want to store only the values without the leading spaces. So in this case, you can do the corresponding changes inside the setter method. Yeah, thanks, Zana. It's already the answer, but I can show it again. So we have the class, right? That's to Svetlana. We have the class, then right-click here, press on source, and here we have generate getters and setters, right? Next to the source section. Also, you can use Alt-Shift-S as it is written here. Also, you can check out any other methods here. We will not go deeper with them, but also you can use them as well. Should be fine. And yes, let's move on with the presentation. And yeah, in general, so we do not want to allow everyone to change the values directly. That's why we need to change or even get, for example, if there is a value with, for example, with the restricted access, like if it's kind of confidential information, before you allow the user to read the value, you want to do, for example, the check if the corresponding user has the access to actually read this value, right? Then in get method you can place the logic which checks the authorization for the read, right? And yes, valid values can be in similar range according to business rules. Then type provides value can be dependent from other values. In this case, need to. Yeah. Also, another case is, for example, if you like, let me just imagine one example from real life. If you, for example, change, okay, I just will provide simple. If you change, for example, if it's requested that if the value A is changed, then the value B must be changed correspondingly, in a corresponding way, right? So in this case, in the setter method, if you set one value, you also need to change another value. But if you set value A, you also need to change the value B based on what is the value of A, and so on and so on. So there could be some dependencies inside the logic. It's not even necessary. So if this dependency is inside the current object or inside the different object, you can just manage these dependencies manage to solve these dependencies using getters and setters. Right. Then yes, you can check values before setting, and yes, you can use, and encapsulation is used to restrict the direct access to the value, to the attribute. Abstractions. Abstraction is also very popular and very important thing in object-oriented programming. Yeah, that's technique to managing complexity of software systems. Yeah, there are different principles how to manage it. The oldest one using structured programming. Also in object-oriented programming, software abstraction deals with classes and objects. Yes, objects have their own properties and methods. Yeah, that's correct, and can be also used to manage hierarchies of objects. We'll talk about abstract classes and interfaces a bit later. In this case, you just need to know that we used abstraction to maybe to hide something, to generalize something, and to make it more flexible for the classes to be defined and to be used. Right. Yes, we'll talk about the abstraction maybe a bit later. We talk about inheritance and the abstract classes and interfaces. Encapsulation, I already mentioned about it. So that's the technique of packing data and methods into an object. Right, if you have something inherited from the superclass, it's also part of encapsulation. Yes, in difference with structured programming, objects know what can be done with them, and their data structures are complemented by their methods. It allows to hide implementation and internal private behavior of an object. This is also, yes, as mentioned, a part of for example, getter and setter methods. They are defined as private, so you encapsulate them inside the class and do not allow them to be changed directly outside the class. So in this case, we need to ask for the access to them using different method, using public methods to access them, but not directly. Yes, modifiers, we already talked about them, and this you can again see the table of modifiers. The default one with no keyword, just nothing. Private, protected, public. We already talked about them. we will talk about them also in future. It's just again just small reminder for you that we can manage to restrict the access using them. Restrict the access to methods or attributes using them. Inheritance. Yeah, this is just a small introduction to inheritance. We'll have a separate topic for it. So yeah, this is approach when one class is based to another class. In this case, the class which is based on another class is called the subclass, and the class which is actually the one on which the subclass is based is called as this is considered as the superclass from the perspective of this class. And yes, and yes, inheritance can be described as is association. Yeah, this is kind of true that they are associated with each other, and yeah, inheritance allows to reuse the common data structure and behavior and extend it only when more complex structure or behavior is necessary. Right, it's also pretty true. More general class from which the class is inherited is called the parent class. Yeah, again, superclass or parent class. That's kind of also the same. And yeah, child class also can be considered as the subclass. So the synonyms from this point of view. Of team. Okay. Yeah, for example, in this case we can see that the parent class, the superclass, is animal, and the subclasses of animal are bird, fish, and mammal. And yeah, another example regarding the computers. Yeah, there's the class there's the class of computers, of all the computers, for example, and we can consider the the particular model of computer as the subclass of the computer class. Yeah, maybe in this case there can be even more subclasses of computer with the hierarchy which goes to this particular model of computer, like computers. Then we can go to computers from, let's say, computers from Asia, then computers from China, then like Lenovo, and after that we can go to this particular subclass. But in general, yeah, this is how it works. Yes, again, polymorphism. Yeah, approach when the same invocation management is used for different behavior. Right? Yeah, again, the general class animal with method move, and it has child classes bird, fish, and mammal with some kind of specialized move, like we did here. We have, like here we had, here we have the square. Then the sub square has its own method which provides us the area of the square. Then we have the subclass which has different implementation of get area method, and then we have the parallelogram with okay, in this case it's also kind of the same, but yeah, it's also kind of the same, but in theory this also can be different implementation here. There can be different implementation here for all the subclasses. So yeah, this is the polymorphism. Theory, yeah, in theory all the shapes, for example, if we have just the class shape, and we have, this is like a superclass for such classes like squares, circles, triangles, and so on and so on. And for all these classes, there are some similarities. Yeah, there are some similarities. Some similar methods can be like construct, but all of them will have or yeah, in most usual case, they will have different implementations. So yeah, this is considered as the polymorphism. Okay, for animal, for example, yeah, for this case, animal has the method move, like you know that bird move in bird flies. Yeah, that's the way the bird is moving. Then we have the fish. Then we have the fish which just swims, and we have the mammal which yeah, let's I hope mammal it calls like simple walk, or yeah, I hope it can be called as walk, but it never mind. It's just yeah, all of them has different way of moving, so the method move has different method. Okay, yeah, in this case it has different implementations within the classes of different animals. Yes, they do different things, but can be involved in the same way. Like, for example, if we scare any of them, they will move, right? Basically, this is the way we call the method. We scare them, and they move. So in this case, we call the method, but the implementation of this method will be different for all these three things. Yeah, this is just an example. And yes, we already faced it today. It's so-called top-down design. So it basically it means that we go. So the superclass must be the most simple, right? The parent class should be the more we go to parent, I mean, if we have the hierarchy from the bottom to the top, then if we move up and up, then we need to consider the class should be even more simple than the one from where we come. Right, and why it is so? Because in general, from object-oriented point of view, it's easier to add some new attributes than to remove them. So why we used here the square as the superclass, because it has the attribute which we can face in all the subclasses. But if we start with, for example, parallelogram, in this case it's pretty straightforward that the square also has the angles, but we know that for square all the angles are 90 degrees. So in this case we don't actually need this parameter to square, but we need this parameter to parallelogram, right? And yeah, that's why we start with more simple. So square has the more simple characteristics than rectangle, and rectangle has more simple characteristics than parallelogram. Yeah, that's why this approach is called from top to down, right? From general to more detailed. Yes, from general to more detailed, and lots of large software systems can be built using this approach, recursive approach. If necessary, then part is already created. Just use it, right? You don't need to write the same code for 10 times or more even. Just try to reuse the existing one. Otherwise, just split the problem in separate independent parts. So that's the keyword here, that all the parts need to be splitted independently. right? And just put them together like this. Yeah, again, here we have digital clock. There are three types, like three it's called subclasses of digital clock. It's clock, date, and counter clock. Right. Then we can see that clock has hour, minute, and second. Then the date has the month and day, and counter has seconds and milliseconds. So we can split it in this way, and for example, we don't need the seconds to date, milliseconds to date, milliseconds to clock, for example, but we need it to the counter, to the stopwatch, and we don't need seconds to date. At the same time, we don't need months to be added to clock. We don't need days to be added to clock. So in this case, it's also very important to create the right schema for you, the right framework to work with it. And yeah, the same approach is used in other software development approaches. Only difference is that in object-oriented programming is that in its structure of objects is created. Right. Divide each difficulty into as many parts as is feasible and necessary to resolve it. Yeah. Also, again, it's very important to divide all this hierarchy into correct ways. Also, there are two very important things in object-oriented programming. It's called coupling and cohesion. Maybe we will not go quite deep here. Just know, first of all, that that we need to. The good approach is to minimize coupling and maximize cohesion. Yes. Regarding the coupling, just top-down design does not guarantee you a good design, right? And you cannot say that design is good before it is implemented. Actually, in good design, the interaction between objects is as minimal as possible. So if we have, like in this case, three different objects, it would be much better if none of them are interacting with each other. All of them should have some properties of the class of digital clock. Yeah, that's true, but none of them should interact with each other directly. Otherwise, that will be that's so-called spaghetti code, when everything is mixed and nothing nothing clear. Nothing is clear. And yeah, that's for example good design. Square, rectangle, circle, and ellipse is shape. Kind of similar for stuff we did today, but yes, maybe the bad design is that square is rectangle. The square is rectangle. That's why there's second and seconds. Yes. Maybe I think that's the typo. Yeah, just regarding to the Maritas question, that's the typo here. I think there should be seconds here as well. But yes, I mean, yeah, you know the difference between the seconds in the stopwatch and the seconds in the clock. I hope. Right? So yeah, there should not be difference. It should be both of them should be seconds. It's just to distinguish them. And yeah, what did we have is that we declared rectangle as the square. Actually, we did not declare the rectangle as the square, but we declare it as the subversion of the square, more generated version. But if we if we went a different way, for example, if we declared the rectangle as the superclass of square, we will have we would have so many different problems. Why? As I already mentioned, there are more attributes needed in rectangle than in square, and in this case, that's why we cannot consider the square as the subclass of rectangle, because again there are more parameters in rectangle, and in this case we do not follow the approach when we go from general to detailed. In this case, rectangle is more detailed than the square, and we cannot consider the rectangle as the parent of square because it's more general than, or it's more detailed than square. And yeah, if we do so, we would finish it not quite comfortable way. But we can use the square as the parent class of rectangle, yes. But we cannot use the square as the subclass of the rectangle. And again, another point is that we need to maximize the cohesion. And yes, cohesion is also called as the law of Demeter. I'll share the presentation with you. You can read it. And check the details about it. So that's the principle of grouping similar objects together, right? Like in this case, we group them, clock, date, counter, and consider them as part of digital clock. Yes, in general, cohesion means the stickness between similar objects, right? Just in case you have, okay, maybe we'll not talk about the web programming at the moment. Okay, that would be a bit trickier, but yes, in general, you need to try to stick similar objects as much as you can. So everything is so all of them are related with each other, right? In good software design, cohesion is as big as possible, and that means that similar objects are grouped using inheritance and composition. Together, different objects are grouped apart, and yeah, this is a good example. That bird, fish, and mammal are animals, and carrot, potato, and cucumber are plants. Then yeah, the bad design is if the bird, fish, potato are considered as my likes. What does it mean? I don't know. Just my likes. If you just select your likes, it's not good for object-oriented approach. And yeah, just start with C. Actually, you must consider what you can do with animals, what you can do with plants, and what you can do with such stuff like my likes, and start with C. I don't actually understand what you can do with the group of object which starts with C. Actually, it doesn't make sense to me. If you want to deal with such objects, I'm not sure what kind of characteristics do you want to get from this parameter, from this description. And yeah, mammal is other. What is other in this case? No one knows. That's why you need to group them correspondingly. Yes, again, from simple to complex. Again, the example we are working on with today is then you go from from simple to more complex. So it's square, rectangle, and the parallelogram. Right. How many slides do we have today? Okay, we are going to finish. Okay, let's finish it. And composition is the approach how to split complex systems into a sum of similar parts. Right, it can be described as has-M association. Yeah, that's also a good thing when you group when you create a kind of association with different classes which have the connected behavior between each other, right? And it allows code reuse where different complex objects have the same simple parts. Yes, right. If you compose some simple parts and use them in different classes, so it's very good. It allows to perform partial implementation and testing, right? And yeah, for example, the car has engine, body, and 4 wheels, and truck has engine, frame, and 10 wheels. So, for example, we can have the class of wheels, and we can use them for car or for truck. That's also fine. But in this case, you need to consider that these will be used as attributes, and we cannot like inherit the class of yeah, we cannot actually, it's not really correct if we inherit the class car or classes car or truck from wheels. It doesn't make sense, right? That car is the subclass of wheels. It's not really correct. Same about truck. But we can use wheels as the attribute inside the class of cars and trucks. It's absolutely fine. Yes, and one more point, maybe we'll face it later, but just need to know that for you that all the objects, all the classes in Java are inherited from Java lang object. This class can be used. We'll talk about it later as well to do the casting of the variables in Java. And also we can transport transport the references using this step. So we can just need to know that every class in Java is extended from class called object. Yeah, and yeah, you can see that, for example, class employee is the same if we write it in the way that it extends object. That's absolutely the same. And also maybe a little here, for example, we are in the method, and you can see that actually everywhere in every class you have the method toString, right? So this is the method which is inherited from class object. It's public and you can use it. Okay, we don't actually have time today to check it out, but we'll maybe check it next lesson. So yeah, it converts every object to string, and yeah, by default it returns object reference. You can use implicitly if one try to concatenate objects, right? It is recommended to override it for custom classes to show the meaningful object data if you want to get some data from object and show it. Yeah, for primitive types can be converted to string implicitly using wrapper classes. And yeah, maybe I will start the next session on Monday with I think there are some small examples to show you about the wrapper classes, and yes, we'll discuss it on Monday. Right, thank you for your attention today. Please start doing your homework for Wednesday. Yes, and install Git to set up it correctly and share your repository with me. so I can check your homework then. And of course, if you have any questions, you can write me. I will not be available today, but tomorrow, if you have some questions until Monday, I will try to answer tomorrow or even on Monday as well. Thank you very much and have a nice weekend. Bye.